Good day, students. Today we're looking at another solution in the series of hypothesis testing. Today's example is an example of a one sample proportion test. Let's get to it. Perfect Pizza claims that 80% of its orders are delivered within 30 minutes after placed. A sample of 100 deliveries showed that 74 were delivered on time. At the 0.10 level of significance, can we conclude that their claim is true? In other words, that 80% of its orders are delivered within 30 minutes. Alright, now have a look at the 5 steps again. 1, 2, 3, 4, 5 written there in the box. So the first thing we have to do is state the null hypothesis and the alternate hypothesis. However, before we do that, what I like to do is always list our information first over here. And I always like to start with what do we know about the population and what do we know about the sample. So in the population, now this time all we get from the population is that P, the probability or proportion, is 80%. So we're given a fixed amount, 80%, which of course we're going to enter into the calculator as a decimal, so I'll change that to 0.80. Okay. Now, nothing else is given about the population, is there? Also, don't forget now, in the book or other teachers may be using the symbol pi for the population proportion. Okay. I use just a lowercase p. Okay. Now let's look at some sample statistics. See if what we're given here about our sample. We're given that a sample of 100 deliveries showed that 74 were delivered on time. So we're given a proportion, see that? And often referred to as p hat, the proportion of the sample. We're given that 74 out of 100, right? In other words, x out of n. Or some people just write the fact that x equals the number of successes, or in this case 74, and n equals the number of trials, or the number in the sample. So either way, you can write it either way. There's no issue there. Now, so that's what we know. Now let's go back and see if we can write our null hypothesis and our alternate hypothesis. So are they delivered within 30 minutes? So the status quo is, of course, HO, right? What is happening now? And that is, now it's not mu anymore, is it? It's P, or pi, if you're using the pi symbol, greater than or equal to 80%, or 0.80. You can write it as a percent, no problem. In other words, that 80% are delivered within 30 minutes, right? So we're staying with the status quo for null hypothesis. And also we're known within 30 minutes here gives us the alternate hypothesis, which is P less than 80%. Okay, so there's the null and alternate hypothesis. Alpha, we don't have to choose it, it's already given, so we're given a 10% level of significance here. Alright, see that? So 0.10. Then we're asked to choose the test. Well, there is no test to choose. It's always a z-test for proportions. Okay, so that step is quite easy as well. Now the decision rule. Decision rule, what are we going to, how are we going to find that? Well, let's look down here for step 4. Let's go down here a bit and do some work on the decision rule. What is our decision rule? First of all, we need to know our critical value. So we need to know that z value, which a lot of people refer to as a critical value, and I use CV as a subscript there, and that's found by inverse norm. Okay, again, your area, it's going to ask you for your area, and the standard the mean of a z distribution, which is 0, and the standard deviation of a z distribution, which is 1. Now, how do we determine the area? Well, you have to determine the test. What type of test is it? And you should be able to see right here, because it's less than, right, we are doing a left tail. So this is a left tail test, which means, and if it's left tailed, it means alpha is equal to the area, right? Or the area is equal to alpha, whatever way you want to say it. So the area is alpha, okay, for a left-tailed test. So this is going to be inverse norm on your calculator, alpha, which is 0.100 and 1. Okay, so let's go over to our calculator now. And how do we do that? Remember, the inverse norm, inverse t's are under the vars button, under distribution, above the vars button, which is second vars, and go down to inverse norm, and area is alpha in this case, which is 0.10 for left-tailed, and it's already set up for you as the mean being 0, standard deviation 1, and we get negative 1.28. Okay, so negative 1.28. So there's our critical value. And what does that mean? Negative 1.28. We go down to our chart, our bell curve, and this is a rough estimation only, don't just to get an indicator of where this is. So say roughly here. Okay, so this is our critical value, and it means that this area in here, okay, is alpha, right? So alpha here is equal to 0.05, and this is, of course, alpha is the probability of rejecting the null hypothesis, right? So that's reject HO area. The other region over here, anything above that, of course, we're going to accept the null hypothesis, or do not reject, I suppose is a better way to say it, but I'll use accept. So therefore, our decision rule is the following. If our z value, which we're going to do in step 5, is less than negative 1.28, we are going to reject the null hypothesis and therefore accept the alternate hypothesis. Okay? So that's our decision rule. Now, let's look at step 5, our conclusion. Well, before we draw our conclusion, we have to run the z-test. So what you're doing now, remember, this is a 1. Well, let's just do it on the calculator, show you what it looks like. Stat, go across to test. Now, we're doing a 1 per sample proportional z-test, which is number 5. 1 sample proportional z-test. So go down to number 5. Whoops. Hit enter. Now the first thing it asks you for is that percent of the population, which we're saying is 0.80. Then it's asking you for the how many was in the successes or in the proportion of the sample. 74. How many were in the sample? How many trials? Was 100, and it's left-tailed, so I have to hit less than. So enter, make sure that's highlighted, and then calculate. And we'll see get a z value of negative 1.5. So again, I'll write that down over here, what we did. It was a 1, okay, 1 sample proportional z-test. That's the button we hit. Okay, and what do we get our z-test value? I'll put a t there for test value. Okay, what was our test value? Negative 1.5. Now where does negative 1.5 come? Right, it comes in this region right here. We can mark it in. It's roughly right there. Negative 1.5. So it's in the reject region. Okay, therefore our conclusion is we're going to reject HO, accept HA, since our value, the test value, comes within or lies within the reject region, if you want to call it that. Notice there's another value in the calculator, the p value, that a lot of people use as well, and this is a bit of an extra. So what it says is p is 0.06, I'll round off, say 0.067, and we know if p is less than alpha, we reject. 0.067 is less than 0.10, so again it verifies our decision to reject HO. Okay, and again, this is an extra. We don't need this test right for this one. It just verifies what we did though with the one sample proportional z-test. The only thing left to do now is to take the answer and write it in words. What can we say? Well, we accepted HA. Now, what's HA? HA is the fact that, no, 80%, less than 80% are not getting their pizzas or orders on time. Okay, so let's say that in words down here. So we'll say fewer or less than 80% of the customers of Perfect Pizza, whatever it's called, yeah, receive their order I before E except after C. Receive their order in less than 30 minutes, something like that. Okay? So there's your conclusion for. And there's an example of what? A one sample proportional z-test. Next video then, I'm not sure, but next video on hypothesis testing is going to go into two sample tests, z, t, and proportional. So have a look at those if you want. Bye for now.